Now let us see the property of beta function. That means let us see first property. First property is nothing but beta of m comma n must be equal to beta of n comma m. Beta of m comma n is equal to beta of n comma m. So let us see how to prove this. So proof, I am going to write for this. Now what is the definition of beta function? Let us write it. M of beta of m comma n is equal to integral 0 to 1 x power m minus 1 1 minus x whole power n minus 1 dx. Now I am going to replace x value as 1 minus y. Now replace x value as 1 minus y. Since if I change the variable x to y, limits also will change as follows. So first of all I have to replace dx value. So differentiate this with respect to y. So that means dx by dy must be is equal to differentiation of 1 is 0 minus d differentiation with respect to y means 0. That means 0 minus 1 you'll get differentiation of y is 1. So that means dx must be is equal to minus dy. So I can replace dx as minus dy. Now at the same times how the limits will change, let us see. Since we know x is equal to 1 minus y, at x is equal to 0 implies 0 is equal to 1 minus y implies y must be equal to 1. So at x is equal to 0 we got y limit as 1. Now at x is equal to 1 implies 1 is equal to 1 minus y implies this 1 get cancelled. So minus y is equal to 0, that means y must be equal to 0. So now as x ranges from 0 to 1, y value ranges from 1 to 0. Now if I take beta definition as equation 1, now from equation 1 I can write beta function as beta of n comma n is equal to integral, since I have to change the limit, as x ranges from 0 to 1, y ranges from 1 to 0, x value I can replace it as 1 minus y whole power m minus 1 into 1 minus x means 1 minus y minus of minus. So 1 minus of 1 minus y whole power n minus 1. Dx value I can replace it as minus dy. So that means integral 1 to 0 1 minus y whole power m minus 1. So 1 minus, if I take this minus inside, you'll get 1 minus 1 minus of minus y. So you'll get plus y. So you'll get y power n minus 1. This minus I can take it outside. So dy you'll get. Now as we have the property that integral a to b f of x dx is equal to minus integral b to a f of x dx. So if I change the negative function to the integrand, limits also we can change. So that means as per this property we have beta of m comma n is equal to integral 0 to 1 y power n minus 1 into 1 minus y whole power m minus 1 dy. Since I have changed the negative value, so limits also will change. Upper limit will go to lower limit and lower limit will go to upper limit. Y power n minus 1 is there, 1 minus y whole power m minus 1 is there. Since if you compare this definition of beta of m comma n, since m value can be written first, since because x power m minus 1 is there, n value can be written as second because it is a power of 1 minus x whole power n minus 1. 1 minus x. So that means, as per the definition, I can rewrite this as beta of y power we have n minus 1. So that means n I can write it as first. Next 1 minus y whole power m minus 1 is there. So it is a power of 1 minus y. So I can write it as next. So finally I can rewrite beta of m comma n is equal to beta of n comma m. So this is about the first property of beta function. Now let us discuss about the second property of beta function, that is gamma of n plus 1. Gamma of n plus 1 is equal to n into gamma of n. Gamma of n plus 1 is equal to n into gamma of n. Let us see how will I prove this. As per the definition, gamma of n must be is equal to integral 0 to infinity e power minus x x power n minus 1 dx. Now here I can rewrite gamma of n plus 1 as replace n by n plus 1. So we will get integral 0 to infinity e power minus x x power n plus 1 minus 1 dx. Since in the place of n we have n plus 1, I have to replace wherever n is there, n plus 1 I have to replace. So integral 0 to infinity e power minus x x power n plus 1 minus 1 can be written as x power n dx. So we got gamma of n plus 1 as e power minus x into x power n dx. Now if I do integration by parts, now by integration by parts, integration by parts, what is integration by parts? Integral u into v dx can be written as u integral v dx minus integral of u dash integral v dx whole dx. So I am going to apply this definition to this one. So now let us see. Before going to apply this, I have to rewrite this integrand part as particular format, that is it should be in the order I late. So that means I means inverse, logarithmic, algebraic, trigonometric and exponential. So first I have to rewrite gamma of n plus 1 as integral 0 to infinity. Exponential should be always on the second place, that last place. That means I can rewrite it as x power n e power minus x dx. So now I can apply integration by parts. Since in the place of u we have x power n, in the place of v we have e power minus x. Now x power n integral e power minus x dx having limits from 0 to infinity minus integral of d by dx of x power n having the limits 0 to infinity. Integration of e power minus x is e power minus x by minus 1 into dx. So this one is equal to x power n e power minus x having the limits 0 to infinity, because different integration of e power minus x is e power minus x divided by minus 1, because x quotient is minus 1, so I have to divide by minus 1. So integration of e power ax is nothing but e power ax by a. So minus integral 0 to infinity differentiation of x power n is n into x power n minus 1. E power minus x by minus 1 is there, so minus of minus will get plus e power minus x dx. So this one is equal to, how to apply upper limit minus lower limit, so minus of, since we have infinity, have to replace limit value as limit as x tends to infinity x power n divided by e power minus x. Let us write it as e power minus x. Sorry, e power minus x can be written as 1 by e power x. 1 by e power x. Why I have written the limit means here, if I apply the limit directly, we have infinity power n divided by e power infinity. Since we know e power infinity value is infinity, even infinity power n is also infinity, so we got infinity by infinity form. So when you get the limits like this, we have to apply the limits. So that is the reason why I have to apply the limits in the lower limit, sorry, upper limit. Now if I replace x value as 0, so 0 into anything is 0, so that means minus 0 I can write. This is about the first term, plus n into integral 0 to infinity x power n minus 1 e power minus x dx is there. Now this one is equal to, if I apply L'Hospital rule for the first term, we get minus limit x tends to infinity. If I apply L'Hospital rule for n times, that means differentiation of x power n for n times, we will get n factorial divided by e power x. Because if I differentiate for one time, you'll get n into x power n minus 1. If I differentiate x for second time, n into n minus 1, x power n minus 2 will get. At the same time, if I differentiate it for n times, we'll get n factorial divided by e power x. If you differentiate e power x for any number of times, you'll get e power x only. Now if I apply infinity in this limit, we'll get n factorial by infinity. Since we know anything by infinity value is 0, so that is the reason why we are going to apply L'Hospital rule here, plus n into, since if you observe this, this is the definition of gamma function. So in the place of this integral, I can replace it as gamma of n. So finally I can rewrite this as gamma of n is equal to 0, since if I apply limit for this term, we'll get n factorial by e power minus x. That means let us apply that limit. Minus n factorial divided by e power infinity plus n into gamma of n. So that means minus n factorial divided by e power infinity value is infinity plus n into gamma of n. So that means gamma of n plus 1. So here in the left hand side we have started with gamma of n plus 1. So gamma of n plus 1 is equal to anything by infinity is 0 plus n into gamma of n. So that means finally I can replace gamma of n plus 1 is equal to n into gamma of n. So this is about the second property of gamma function. So these are the first two properties of beta and gamma function.